Hello everyone. So welcome to the lecture series on the concept of importance of mathematics towards engineering. So further into this, now we are going to discuss about differential calculus. So since in the previous discussions we saw enough amount of concepts towards matrices towards mechanical engineering, now I am moving into the concept of differential calculus. So as you know, differential calculus is very important for the field of engineering. So let us discuss the power of differential calculus and its applications in the field of mechanical engineering. So in your day-to-day life, we can see each and everything in our life can be connected with differential equation if there is a rate of change. So when there is a rate of change, I could say sure we can work with differential calculus. So if there are some variables connected with it, and if one variable is connected with the other, so we can check which is the independent one and which is the dependent one, and we can work more into this. So as a introduction to differential calculus, the fundamental idea starts with the change, the rate of change of one variable with respect to other variable. That was the fundamental idea behind differential calculus. So it is a study of rates of change and slopes of curves. Slopes are nothing but there is a rate of change of x with respect to y or y with respect to x if you talk with a graph. So if you take the key concepts of differential calculus, we can talk about the derivatives, we can talk about limits, and also we can talk about instantaneous rates of change. So as one of the application, let us talk about the differential calculus importance in kinematics. Velocity as the derivative of position. So when you talk about velocity, it is the rate of change of displacement. So according to the change in the time, so what is the displacement happening? There we talk about velocity. So velocity can be connected with the derivative of position, because with respect to change in time, obviously there is a change in the distance. So rate of change of displacement with respect to time leads to velocity. The next concept is acceleration. The rate of change of velocity is called acceleration. That is, we call it as second derivative, or we can say the differentiation of velocity gives acceleration, or if you differentiate the distance twice with respect to time, we get acceleration. So in any one of the way, so acceleration can be told as the derivative of velocity. And the next one is predicting future positions and velocities. So taking in account the current data, the initial conditions, the present conditions available, we can work for the future ideas. That is, we can predict the future positions, velocities, or even further into it. So you can find n derivative terms. So we can find the order of the derivative, degree of the derivative, and we can move further on, so that you can find lot of analysis ideas, and you can bring out a lot of solutions. So you can predict the future, that is by predictions. So that is why it is very, very important. The reason is it is a very important tool. You can see it can easily measure the rate of change of a variable. It is not that it is going to measure with respect to one variable. It can measure with respect to multiple variables. For example, if you take heat and mass transfer, you can see there multiple independent variables may be available. So one dependent variable will be connected with multiple independent variables. So even we can work into that. So even we can find solutions in it. Thank you for listening this video. Thank you.